Okay, good morning everyone. You are welcome to this Simplify All STEM tutorial. Today we are looking at something very important, which is what calculus. And we know that in calculus we have differentiation and integration. But today we are going to look at what differentiation. And what we are going to consider under the differentiation are some rules of differentiation. Now let's look at number one. We have power rule. Power rule. Power rule. What does this rule mean? Power rule is letting us know that if y equals to what? If y is equals to x raised to the power of n, if y as a function is equals to x raised to the power of n, for us to be able to find the derivative, which is dy over the x, dy over the x, this is like the formula for power rule. Dy over the x, for us to be able to get dy over the x here, you know that this is a function raised to a power, right? Now, if you have a function raised to a power, the power now, which is n, we multiply the function. That means n, we multiply the entire function of x raised to the power of what? N, right? That means this power now, n, is multiply the entire function. Then we subtract 1 from the power. I hope you understand. That means if you have a function y equals to x raised to the power of n, then for us to find the derivative, which is dy over the x, we are going to use this method, this formula. The power n, we multiply the function, which is n multiply the entire function, which is x raised to the power of n, right? Then the power now, we are going to subtract 1 from the power. So this is the method for us to be able to find the derivative of a function using what? Power rule. So let me give us some example. Let's look at example 1. This is a basic thing that you need to know in differentiation. Example 1. If y is equals to what? X raised to the power of 3, right? If y equals to x raised to the power of 3, for us to be able to find, they say we should find what? Find dy over the x. Find what? Dy over the x. For us to be able to find dy over the x, look at this formula that I gave us. Dy over the x is that we are using the power to multiply the function and then subtract 1 from the power. So let's use this method to solve this guy. Then let's look at the solution. Right? We are given y equals to what? X raised to the power of what? 3, right? Now y equals to x raised to the power of 3, right? Now let's look at dy over the x. We are differentiating y with respect to x. That is what we mean by dy over the x. We are differentiating y with respect to x. If this was let me just say, if this was t raised to the power of 3, this is what to be what? Dy over what? Dt. But since this is x, you say that is dy over what? The x. So in this case now, dy over the x, by using this formula, this is the power, right? X is the power of 3, right? So for us to get dy over the x, that means this 3 now, we multiply the entire function. So we're going to have 3 multiply this entire function, which is 3 multiply the entire function of what? X raised to the power of 3, right? That is the first step. Now you subtract 1 from the power here. The power 3, subtract 1 from the power 3. So we're going to have, this is going to be what? Equals to what? 3 times 3 to the power of 3 is what? 3 times x to the power of 3 is going to give us what? 3x, right? And you know, if you subtract 1 from 3, you're going to have what? 2. So therefore, our dy over the x is equals to what? 3x raised to the power of what? 2. So this is the final answer. This is how to find the derivative using what? Power rule. Don't forget that when I talk about this power rule, if you have a function y equals to x raised to the power of n, for us to find dy over the x, the power now, the n here, we multiply the entire function, which is going to be n multiply the entire function x to the power of n, right? Now you subtract 1 from the what? Power. This n now is representing our power. Now for proper understanding, I gave us an example that if y is equals to what? X to the power of 3. For us to find dy over the x, which is the derivative, you know that what we give us, the function we have here was what? Y equals to what? X to the power of 3, right? Now for us to find dy over the x, by using this formula of power rule, You know that the power here 3, we multiply the entire function, which is x to the power of 3, right? Then you subtract 1 from the power, that is going to give us dy over the s equals to what? 3x square. So this is how to use a power rule in differentiation. Now let's look at the second rule of solving differentiation. Okay, now let's look at the second rule of differentiation. Now, the differentiation of constant. The differentiation of a constant, that is dy over the s is equal to what? 0. Where c is what? Constant. Let me explain this using what? Example. Now, if you have example, let's look at this example. Please pay attention. If y is equals to what? 5, right? If y is equals to 5, they say we should find dy over the x, right? We should find dy over the x. For us to find dy over the s in this case, you know that dy over the x, pay attention, dy over the s is equals to what? We give us 0. Why dy over the s give us 0 is that when you are differentiating a function, which is constant, you know that this 5 now is a number, right? It did not attach by any variable. It did not attach by x or any variable. So since we are differentiating a function that does not attach with any variable, it's going to give us 0. Even though it's 100, 1000, as far as there is no variable attached to it, it's going to give us 0. Let me prove that for us. Let me prove that for us. Or let's look at this method. You know that y equals to what? Y equals to what? 5, right? They say you should find dy over the x. I'm going to prove that for us. For me to be able to find dy over the s, right? Now, let's look at the solution here. Look at it. If y equals to 5, right? To find dy over the s, I say, well, let me prove that for us. Why it is 0. If you let's look at the solution. Now, we know that y equals to what? 5. And I told us recently that if you are differentiating a constant, you're going to give us 0, right? Since there is no variable attached to the numbers, right? Let me prove how we get it. Now, for us to get dy over the x, we are differentiating the y with respect to what? X, right? Since we are differentiating this y with respect to s, I say that let this guy become what? 5, right? Attached by x in this case. But 5 attached by s, I put what? 0 here. Understand? Based on law of indices, anything raised to power of 0 is what? 1, right? And 1 times 5 descending as what? 5, right? So it's descending as this guy, right? That's good. Now, for us to be able to differentiate this guy, since we are differentiating with respect to x, I say that now this implies, look at what I'm doing, this implies that our dy over the x is equals to what? By the power rule method that I told us that recently, that this power will multiply the entire function and you subtract 1 from the power, right? Let's apply this here. So we're going to have 0 now. This 0 will multiply the entire function. That's why I have 0 here. 0 multiplied by what? 5. This is the power of what? 0, right? Are you seeing it? 5 is the power of 0. Then you subtract 1 from the power. Then subtract minus 1. So we're going to have our dy over the x equals to what? You know that this is 0, right? Times 5. This is the power of 0 minus 1 is what? Going to give us minus 1, right? Now, therefore, our dy over the x is equals to what? Our dy over the s is equals to what? 0. Because anything multiplied by 0 is what? 0. That is why we say that the derivative of a constant is 0. I hope you understand. Okay, that's nice. Let's look at the second rule in differentiation. But before we look at the second rule in differentiation, I would like to combine the first power rule and this constant rule together, and let us find how to derive them. Let's look at it. Look at this. Let me give us this example. I just combine the power rule and this constant rule together. You know that we differentiate this guy before. I say if y equals to x to the power of 3, right, plus 5. Now I'm combining these two functions together. If y equals to x to the power of 3 plus 5, find dy over the x. Now let's find them one after the other. We're differentiating them one after the other. Solution. You know that our y is equals to what? X raised to the power of 3, right? Plus 5. Now for us to find dy over the x. Now our dy over what? The x will be equals to what? If you differentiate this guy first, this first one. You know this is power 3, right? The power 3 will multiply the entire function, this guy here, which is what? S is power of 3, right? This is the first step. Then you subtract 1 from the power. You understand? That's good. Then pros. We are done with the derivation of this first one. Then we come to the second one. This is a constant. And I told us that when we are differentiating a constant means a number that is not attached with any word variable, right? So if you are differentiating this 5, because we are differentiating with respect to x, I say that this become what? This is what? I say that since you are differentiating with respect to x, right? I attach x with the I attach x with the 5, right? And add it with what? 0, right? Do you understand? I add it with 0 because based on law of indices, anything raised to the power of 0 what is descending as 1, right? And 1 times 5 descending as this 5, right? You understand? Now, for us to be able to derive this guy separately, let me come down again so that we understand what we are doing here. You know that I've already derived the first one, which is 3 times what? X raised to the power of 3, then subtract 1 from it, right? Now let's derive this guy. Pros. Now, this thing raised to the power of 0, right? 0 multiplied by 5 is going to give us what? 0 times what? 5x, right? This x here raised to the power of 0, right? That means the power is multiplied everything in all this function, right? So this is going to be 0 multiplied this function, then subtract 1 from the function based on what I did recently. Now we're going to have, therefore, our dy over the x is going to give us what? 3 times x is what? Going to give us what? 3x, right? Then 3 minus 2 is going to be what? 3x squared, right? Now look at this guy. Pros. 5x raised to the power of 0 minus 1 is going to give us 5s raised to the power of minus 1, right? Then you multiply by 0. Anything multiplied by 0 is going to give us what? 0. So therefore, our dy over the x is equal to what? 3x squared. And this is the final answer of the derivation of this y equals to x cubed plus 5. Because when we derive the constant here, it's giving us what? 0, right? I hope you understand this. Okay, that's nice. Let's move on to the third rule in differentiation. Now, let's look at the third rule in differentiation. Please pay attention to this tutorial. I want you to just get the best out of this tutorial. Now, we have what they call product rule. We use product rule when two functions is being multiplied together. Pay attention. I said that what do? We use product rule when two functions is being multiplied together. Know when to use product rule, know when to use quotient rule and chain rule, different rule in calculus. That is the importance of what calculus. That is, we need to pay attention on this. Now, for us to be able to apply product rule, we use it when two functions is being multiplied together. Now, if you look at this guy, it says if y is equals to what? uv. This u is a function, this v is a function, right? So if you have two functions being multiplied, for us to use product rule, for us to find dy over the x using product rule, our dy over the x will be equal to what? U, the first function, multiplied by the derivative of the second function, which is the v, the x, plus the second function multiplied by the derivative of the what? First function, which is the u, the x. I hope you understand. Okay, let me use example so that you understand it more deeper. Let's look at example on this guy using product rule, right? Let's look at the example. It says if y, right, is equals to, if y is equals to x times what? X squared, right? This is what? It's a two function. This is x, right? And this is what? X squared. You can use a product rule to solve this guy because two functions is being what? Multiplied together. Now let's look at how to, they say you should do what? Find dy over the x. There's two ways of finding this guy. You can use shortcut methods of finding this guy, which is you can use a power rule by saying x times x squared give us what? X cubed, right? X cubed. Now you say dy over the x. That means the 3 will multiply this x cubed. You're having 3x cubed minus 1. So it's going to give us what? 3x what? Square. It's supposed to be the final answer. But in the case of using this product rule, I want to explain in a way that in case the question is not in form of x times x cubed, you can use product rule to solve it, because sometimes they can state it to use what? Product rule. Sometimes they will not state it, they will just show you the two functions. So let's apply product rule by solving this guy. Now let's look at solution. I hope you are following. Please just pay attention to the solving. You know that y is equals to what? X times what? X squared, right? Now from this guy, you know that this is u, right? If y equals to what? Uv. So let's just say, let u be the first function. Let u equals to what? X, right? You understand? Then, and v, you know that the second function is v, right? And v be the second function here, which is what? And v equals to what? S cube. I hope you are following. That's nice. Now let's find the derivative of each of the function. We have gotten u and we have gotten what? V. From this formula here, you need to find the v, the x, right? And you need to find the u, the x, right? Now let's look at what? The u, the x. The u, the x. The u, the x here is telling us that we are deriving the function u with respect to what? X. We are deriving the function u with respect to x. That is what the u, the s mean. So if you are deriving the function u with respect to x, this is the value you have here in the function of u, right? But based on law of indices, you know that this x is raised to the power of 1, right? If you are using power rule to derive this guy, always remember our power rule is very important when finding derivative of a function in calculus. You know that this x is raised to the power of 1, right? That's good. Now, if this s is raised to the power of 1, because anything raised to the power of 1 is the same thing as that term, right? So there's an invisible 1 on top of this x. So we're going to use that 1 to multiply the function of x, right? Based on power rule. Then the 1 is still there, right? You understand? That's good. The 1 is still there. Then we subtract 1 from the power. Based on power rule we apply then. Based on power rule we use. Now we're going to have 1 times s is going to give us what? X, right? You understand? That's good. Now 1 minus 1 is going to give us what? 0. And we are having s raised to the power of 0. By the law of indices, anything raised to the power of 0 is what? Is equals to 1. Therefore, our du over the x is equals to what? 1. I hope you understand. That's good. We are getting our du over the s. Now let's find our dv over the x. Our dv, also, our dv over the x, pay attention to this. Our dv over the x, when we have our dv over the s, that means we are deriving v with respect to what? X. That is what dv over the s mean. We are deriving v with respect to what? X. Now, for us to be able to derive this guy, you know that based on power rule, I said that the power will multiply the entire function, right? And the power we have here is what? 2. So we're going to have 2 multiply the entire function, which is x squared, right? Subtract 1 from the power, which is going to be minus what? 1. 2 multiply the entire function here, going to give us 2 times s squared, then minus 1. That's how I got this thing. 2 times what? S squared minus 1. 2 times s squared is going to give us what? 2, right? X, right? Then if you say 2 minus 1, it's going to give us what? 1. There's an invisible 1 here. And anything is to the power of 1, the same thing as what? The same terms, right? Which is x. So our dv over the x is equals to what? 2x, right? That's nice. Now, we have already gotten all our parameters from product rule. We are getting u, we are getting dv over the s, and we are getting v, we are getting du over the s. Let's substitute into this formula. Now, by product rule, we know that our dy over the x, right? By product rule, our dy over the s is equals to what? U dv over the x plus v du over the x, right? That's good. You know that our u is what? Our u is what? Look at what? Our u is what? X, right? So we're going to have our dy over the x. Our u is what? Is x, right? You put x here. Hope you understand. Then our dv is what? Our dv ds is what? Our dv ds is what? 2x. So you put multiply by what? 2x. Then this plus here, put plus. Our v is what? Look at it. Our v is what? X squared, right? X squared. Our dv over du is what? Look at dv over du. Look at dv over du. Check it. Our du over the x is what? Our du over the x is what? 1. Hope you understand. That's nice. Now, therefore, our dy over the x is equals to what? X times 2s is going to give us what? 2s squared. Because this is the power of 1 and this is the power of 1. Based on law of indices, when they are in the same base and they multiply together, we add their power together. So we're going to have 2x squared, because 1 plus 1 is what? 2. Then plus, look at this guy, x squared multiplied by 1 is going to give us the same thing as what? X squared, right? That's good. Therefore, our dy over the x is equals to what? 2x squared plus s squared is going to give us what? 3x what square, and the same thing as the power shortcut method I told us recently, which is this is the final answer of using what? Product rule. I hope you understand. Thank you very much. Let me just recap it. Now we talk about product rule. You say that we use product rule when two functions is being multiplied together, right? And now you have y equals to u v. U stand for one function, v stand for another function. When these two functions be multiplied, we use what they call product rule. And for us to be able to apply product rule, for finding the derivative of the function, which is dy over the x, this is the formula. Dy over the x equals to what? U times dv all over the x plus v times du all over the x. Now let's look at an example for us to be able to understand what product rule mean in differentiation. If give us an example, if y equals to what? X times x squared, right? They say you should find dy over the x. Let's look at the solution. These are the question they give us. Y equals to what? X times x squared, right? Now this is a two function. This x is another function and this x squared is another function. If you don't want to use power rule method to multiply them and just find the derivative, you can follow this product rule. Now know that u, I said let this first function be what? U. So I say let u become the first function, which is equals to x, and I say let v become the second function, which is what? X squared, right? Now we have gotten u and what? V, but we have not gotten the v, the x, we have not gotten the u, the x. So now let's find the u, the x. The u, the x means that we are deriving the function u with respect to x, which is the variable. Now for us to differentiate this guy x, you say that the u over the x equals to what? Now if you look at this x, based on power rule, I said that the power will multiply the entire function and we subtract 1 from the power, right? So if you look at x, x has an invisible 1 on top of it, because anything raised to the power of 1 is the same thing as that terms, right, or that number. So 1 multiplied x, right? We're going to have 1 multiplied by x, and the invisible 1 is there, all right? Then we subtract 1 from the invisible 1 based on the power rule, right? So we're going to have 1 multiplied by x to the power of 1 minus 1. That is it. Now we're going to have 1 multiplied by x going to give us x, right? Now raised to the power of 1 minus 1. 1 minus 1 is going to give us 0, right? And based on law of indices, anything raised to the power of 0 is what? 1. That's why when we derive the u, the x, we are getting what? 1. Yeah, we are already gotten our parameter the u, the x. Now let's find our parameter the v, the x. Now for us to find the parameter the v, the x, you know that our function is v, right? This is our v, and is equals to what? S squared. For us to derive this thing s squared respect to v, we are going to have the v, the s. I said that the power will multiply the entire function. The power here is 2, right? So 2 multiplied the entire function, which is x to the power of 2, right? Then we subtract 1 from the power, which is 2 here. So we're having 2 multiplied by s to the power of 2 minus 1. You know that 2 multiplied by s is going to give us 2s, right? 2 minus 1 is going to give us 1. There's an invisible word 1 here, because anything raised to the power of 1 is the same thing as that terms or numbers. That's why I have 2x. Now we are getting all the parameters. We are getting our u, we are getting our u, we are getting our dv, the s, we are getting our v, we are getting our dv, the u, the x. Let's substitute them into the formula. Now by product rule, we know that dy over the x equals to what? U times dv over the x plus v times du over the x, right? Therefore dy dx equals to what? Our u is what? We know that our u is what? X, right? So we put x in place of u. Our dv ds is what? You know that our dv ds here is what? 2x, right? You put it in place of dv ds plus our v is what? Look at it. Our v is s squared, right? So we put our s squared in place of v. Then our du ds is what? Our du ds is 1. We put 1 in place of du dx. Now we try to expand them. S times 2x, we're going to have what? 2s squared. Because based on law of indices, anything that have the same base, when they multiply, we add their power together. There's an invisible 1 here, and there's an invisible 1 on this x. So 1 plus 1 is going to give us what? 2. And we take only one of the terms, which is x. That's why I have 2s squared. Then plus, you know, s squared times 1 is the same thing as s squared, right? So therefore, our dy over the x is equals to what? 3x squared. Because we add them together, they are in the same base. This is a coefficient. This have a coefficient of 1 in front of this s squared. So if you say 2 plus 1 is going to give you 3, right? Now it correct only one of the word terms, which is s squared. That's why I have our dy over the s equals to 3s squared. I hope you understand. Okay, that's nice. Let's move on to the other rule in differentiation. Okay, now let's look at some derivative of some basic function in differentiation. Now I need to pay attention to this, especially this part, because it's very important. You need to know this. Number one, if y equals to what? Sine x, right? If y equals to sine x, they say you should find dy over dx, right? Find dy over dx. For you to be able to differentiate sine x, the dy solution, the dy over dx, when finding sine x, is going to give us what? Cos x. If you say if y equals to what? Sine x, find dy over dx. For you to find the derivative of dy over the sine x, you're going to give us cos x. Pay attention on this. Now, second one, if y equals to what? Cos x. For you to find dy, for you to derive cos x, for you to find dy over the x of cos x, the solution is going to give us what? Dy over the x of cos x is going to give us what? Minus sine x. When you differentiate sine x, it's going to give us cos x. When you differentiate cos x, it's going to give us minus sine x. Pay attention to this. It's very important because you are going to see it when you are deriving a function. So you need to know it. But if they say you should prove it, that one is different from what? Finding the derivative. This one, just know in mind that if you want to differentiate sine x, it's going to give you what? Cos x. If you are differentiating cos x, it's going to give you what? Minus sine x. This is very vital. You need to know this so that you can be able to apply it when finding the derivative of a function in calculus. Now let's look at the third one. If y equals to what? Sine this exponential x, right? They say you should find dy over dx. For you to get dy over the x of sine of exponential x, the solution is going to give us what? Dy over dx is going to give us the same thing as what? Exponential x. When you derive exponential x, the derivative is still going to give you what? Exponential x. Pay attention to this. Sometimes you might see all this cos x, sin x, or exponential x in a function that is mixed with other what? Variable. But know that when you are differentiating them, you know their derivative. The derivative of what? Sin x is cos x. The derivative of what? Cos x is what? Minus sin x. And the derivative of exponential s is the same thing as what? Exponential x. Now let's look at the fourth one. The fourth one. So if y equals to what? If y is equals to what? Tan x. If y equals to tan x, they say you should find what? Find dy over the s. If y equals to tan x, find dy. For us to find dy over the s of tan x, our dy over the x of tan s is going to give us what? Sec square x. Sec square x. This is the derivative of what? Tan x. Just know their derivative, even though you don't know how they come about. But if you want to prove it as a mathematician, that's how we prove it. But if you don't, what matters now at this level is to know their derivative, which is the derivative of tan x is what? Sec square x. So they can be able to derive the function and get the right answer. Now let's look at the fifth one when finding their derivative of some of these basic function. Now let's look at the fifth one. If y equals to what? Cot x, find dy over the s. For us to get dy over the s of cot x, our dy over the s is going to give us what? Our dy over the x of cot x is going to give us minus cosec square what? X. This is the derivative of this cot x is minus what? Cosec square x. Just pay attention to this. This is very important. Some basic derivative of what? Basis function. Now if you want to find dy over the s of sine x, it's going to give you cos x. Know that it's cos x you're going to have. If you're going to find the derivative of cos x, you're going to have what? Minus sine x. If you're going to find the derivative of exponential x, you're still going to have what? Exponential x. If you're going to find the derivative of tan x, you're going to have what? Sec square x. If you are going to find the derivative of cot x, you're going to have what? Minus cosec square x. Why I'm saying this is that because you're going to see it when you're going to solve some past question in this differentiation. So you need to pay attention to them, know them, so that you can be able to use them appropriately. Thank you. Look at this. If y equals to log, natural log of e raised of s, say you should find dy over the x. Our dy over the x is going to give us what? Our dy over the x is going to give us 1 all over x. Remember that when you are deriving log e raised to the power of x, the derivative is going to give you what? 1 all over x. Don't forget this. It's very important. Now let's look at number 7. Let's look at number 7. Say if y equals to 100, this 100 is a constant. It's not attached with what? X, right? It can be 100, can be 20, can be 10, can be 5 or 1 or 0. When you are deriving a constant, our dy over the s is going to give us what? 0. So please just pay attention to all these standard derivative of every function that I gave us here, because we're going to apply solving past question. And then if you have any question, I would like you to drop in the comment section. And I also want you to do this assignment for me. If you are watching this video, I want you to do this assignment and also submit it in the comment. I want you to do this assignment. Number 1, if y equals to what? 3x cubed, find dy over the x. Number 2, if y equals to what? 2x cubed plus cos x, find dy over the x. Now look at this cos x. You know how to derive cos x, right? When you derive it, you put it here. You know how to derive this guy, you put it here. Thank you very much. Please, if you are new here or you are not subscribed to this channel, I would like you to subscribe to this channel and then like the video, share it with your classmates, your colleagues, and everyone in need of what? Mathematics, so they can build a strong mathematics together and get the best out of our study. Thank you. I love you.